right. Just let somebody else come in. So as with all our Windows Phone sessions, right at the end of this, we're going to give away a phone to one lucky person in this room. You'll all have been given a card. So right at the end, I'll just, when we're kind of wrapping up, we'll collect those in, and then we'll draw somebody go away with a Lumia 920 phone. Very nice. Anyway, before that, you have to listen to me for a little while. I'm Andy Wigley, technical evangelist working out of the UK. And I've been presenting for the Windows Phone group for a long, long time. Proud to have done so. And got a lot of experience with mobile development, going ways back. You know, right from the early days of WAP browsers through Pocket PCs and embedded solutions and ruggedized devices. And today I found myself spending most of my time talking about the Windows Phone platform. This is the Windows Phone 8 Networking Survival Toolkit. So what I want to try and do with this session is, what it is a collection of best practice and good advice and good tips and essential stuff you need to know in order to create effective apps that use networking. So it's a kind of a tool bag of useful stuff. That's really where we're getting at. So I'm going to talk about using async and await for HTTP programming. That's a kind of best practice thing. About good design for data services. I think too many mobile developers just don't think hard enough about the nature of connectivity and the fact that actually mobile devices are running on pretty poor quality networks a lot of the time. So you can do some simple stuff to really stack the cards in your favor. So it's about that sort of thing. And obviously a key part of that is using compression on the wire for efficient data transfer from your servers to your devices and vice versa. Services need credentials, so a little bit about storing your credentials securely. And then I'm going to sort of change tack a little bit and talk about a few other topics that are related to networking in a broad sense. But first of all, I'm going to talk about how you can store. There's a great SDK for storing stuff in SkyDrive, which has a number of nice features you can easily add into your mobile apps. I'm then going to talk about something that's specific to developers, which is how you can access local services while you're developing stuff, while you're building out your solutions. You've created yourself a website or a web service or something, and you're running it on your development box. You know, having the emulator connect to that, you would think would be pretty easy. It's not. So just I'll run you through how that happens. And then I'm going to do a little bit on NFC, tap to connect and tap to share. So just a brief introduction to NFC and some of the cool stuff you can do with that. So hopefully, at the end of this, you will go out here being a Windows Phone networking guru. Now, the theme for the show for us, this TechEd, is that Windows Phone is the right choice for business. And of course, we've got great support. Some of these features like NFC are supported across tablets and phones. And we've got great support for Office 365. But this is really where this talk fits, about being a robust platform for mobile apps. We've got great support for networking. So this is really what I'm focusing on in this talk. And of course, we've got a good device management story. So into content for this, HTTP program with async and await. So how many of you have actually done any programming with async and await? Okay, actually, yes, it's good. Every time I give this talk, it's kind of half, 2/3, or a third, or this sort of thing. So it's still pretty new to a lot of people. But so if you haven't used it yet, async and await is this new way of doing asynchronous stuff, a new way of programming it, which actually makes it easier to program, mostly, and but it also makes it much harder for you to accidentally lock up your UI. And that's really what it came for. It came out, so C#5 includes it, and it's the only way of doing a lot of stuff in the Windows 8 Store APIs. And what they did was, when they were building out the Windows 8 Store APIs, they were looking at all of the APIs, the .NET APIs that we've been using over the years, and they looked at everything that could take more than 50 milliseconds to execute. And if those APIs, and typically obviously this means networking stuff, file handling, this kind of thing, any of those APIs, the old synchronous APIs, were completely removed and not available in Windows 8 Store apps. And instead, you've got all these async methods So it means anything that has the potential for being a long-running operation, the only way of doing it on Windows 8 Store apps is using async and await, which has the effect of running this long-running task on a background thread. So it means that your UI cannot get locked up. You can't inadvertently kind of freeze it up. And obviously networking, HTTP web request is one of the APIs that had this treatment. The old get response methods, they're not available. Instead, we've got get response async. And we've got a whole new API as well on Windows 8 Store apps, HTTP client, which is just designed as being the new API for doing HTTP networking. We don't have async and await methods built into the HTTP web request APIs by default, the ones you get in the SDK. So it's not in there. And we also don't have HTTP client in the Windows 8 Phone 8 SDK. But a lot of stuff is happening since that SDK was released. The end of November last year, and we now have HTTP client has been released on NuGet, so we have that solution is available to us. And a lot of people have been working and building out extension methods which add in async and await support to the traditional APIs, HTTP web request and web client. These are those APIs. So web client is what we've used for simple HTTP programming. Obviously available on 7.1 and Windows Phone 8. Not available at all on Windows 8. HTTP web request is available across all of those three platforms. But like I said, the Windows 8 flavor of that is async only. When we get to HTTP client, now when I used to give this talk, you used to have red crosses under Windows Phone for that. But now, thankfully, we have got it through NuGet as an add-on package. So we've got good support for that. And then there's a couple of other convenience APIs used on Windows 8, Syndication Client and Atom Pub Client, which are only on Windows 8. I'm not too worried about them. Then if you look down the bottom, we've got the web services support. So for old school, if you like, ASMX, SOAP-based web services, good support for them across the board. WCF services, again, good support, and OData as well. I'm going to be touching into a few of these on this talk this morning. So why is async and await better from a programming point of view? Well, if you look at, this is the web client API, which is nice and simple, which is how we would have used, built a simple HTTP calls in Windows Phone 7.1. And as you can see in the constructor on the page there, we knew up a web client instance, but then you have to hook up a completion event handler. So this is one of the ways that async stuff used to be handled. You have event handlers that fire, events that fire when an operation is completed. And then at some point later on, in the load button click at the bottom there, you're actually going to make the call. So there's a methods on web client, this download string async, download file async, upload file async, and upload string async. So in this case, we're calling download string async, we're making a call to a service, we get a string back. And that, of course, is handled in this event handler. But you see, the code's jumping all over the place. It's non-linear, it's just messy, and it's simple enough, but it's just messy. Contrast that with web client, where we're using one of these extension methods where we've added async support in it. Looks like synchronous code, doesn't it? It's like, new up an instance, make the call, handle the response. And it looks like it's happening all on the UI thread. It's not. Because what actually happens is, when you're writing your code and you put in a call to an async method, which actually returns a type of task of T or task, when you make a call to that, like that download string task async, you'll put the await keyword in there ahead of it to say that we want to await for completion of this. Now what the compiler, and then the compiler actually in Visual Studio will force you to put the async modifier on the method. Now what the compiler actually does then, when it compiles this, is this simple method ends up being a rather more complicated full-on state engine. And at runtime, what happens, we knew up our web client instance as normal, and then we get to the await client.download string task async, and at that point, the state, the volatile state of this method, the variables and everything, it's all saved away. The operation is spun off onto a background thread, and actually this method then exits. It suspends, if you like. And so the UI thread, where this is probably executing, is free to handle the user's interaction. The user doesn't get any stuttering. They don't see the UI freezing or anything because it's completely unimpeded. Now, when this call actually completes, then the process unwinds. So the stored state is restored. The method starts executing again exactly from the point where it left off and carries on as if it's never been away, back on the UI thread. So it's kind of split into two in this case. And as you can see, the result here is it's win-win for the user because they don't have any, there's no kind of, the UI is not freezing up. It's win-win for you as a developer because your code's simpler. And actually there's a lot more happening as well. So if you get an exception happens down on that background thread, that's automatically marshaled back and is thrown here. So there's no error handling shown on this slide, but you put a try and catch around that. You just handle the exception up here. You don't have to worry about marshalling anything back from background threads. And of course the response, string response equals there, that comes back in the originating context as well. So there's no event handlers happen to be firing on background threads. None of this dispatcher.begin invoke stuff that you were maybe used to using in order to ensure that some code that might be executing on a background thread actually gets executed back on the UI thread. So nice and clean, very simple. It's a much, much nicer way of doing this kind of app development. Here's another example. This is HTTP client. This is the new HTTP client. So this is the one that's on NuGet. In actual fact, I've been struggling to keep up with the pace of change of this because just 2 days ago, they RTM'd HTTP client version 2.1, and 2.2 is in beta. That's the bullet point at the bottom. Just at the moment, there's a new beta available, which also has automatic decompression in it. So anyway, this is how you basically use an HTTP client. New it up, you can set some request headers, and then again, it's got sort of get async methods on it to make a call on it. And if you're doing code that you want to reuse across your phone apps and your Windows 8 Store apps, then this is the one for you, because HTTP client now is supported across all the different platforms. So I've got a rather unspectacular demo, just to prove that it really all works. So this is obviously using the HTTP client. This is the brand new. Actually, what I've done is I've knocked up a sample. So it actually differs slightly from what I showed you on the slide. So this is the brand new HTTP client. So I've gone into manage NuGet packages. And actually, I've got installed already into this a whole bunch of stuff. But the important one is this HTTP client. I'll just uninstall it again, and it will tell you. Maybe I shouldn't have done that. I'll take that out and then put it back in again just to show you. So actually I've got JSON.NET, which is for JSON decompression. But then we can go online to NuGet and we can go and find HTTP client. And HTTP client libraries, install that. There's a bunch of I accepts on that. And then there's a whole bunch of extra packets. All those other ones get pulled in. So that's why you end up with this long list. Oh, that's slightly shorter. That's slightly worrying. Okay. And this in the loaded thing, this code that's just executed is in the application page loaded. We knew, first of all, this is the actual HTTP client that does the work, but this is a theme I'm going to bang on about this morning. I've also used an HTTP client handler which comes with it, and you can set automatic decompression on that, which also allows us to handle zipped content. And you always want to handle nearly always want to handle compressed content. And then you've got your HTTP client. Yes, we can set some request headers, and then we call get async. And there's useful methods on it. Ensure success status code, checks for a 200, and if you haven't got a 200 or one of those, it will actually throw an exception, which is why we've got this try catch around here. And then we just simply read the data, another awaitable. We deserialize the object using JSON.NET. I'm not going to talk too much about that. Into in-memory objects. We show how big it was, just for interest. And then we show it on the screen, which is what we are looking at here, which is actually the suppliers from the, what we've done is we've gone off to the services.odata.org northwind.service, so that's the suppliers data from the Northwind database, which is being published by an OData service. More on that in just a moment. But the point is, it's clean code. It's actually one method doing all of that networking, making the call and handling the response. It's cleaner from a developer point of view, much nicer. Okay. Now, how many people have the good fortune to live in an area with 4G mobile data connectivity? Yeah, that's right. It's great, isn't it, if you've got it? Not so great if you haven't got it. And I get slightly annoyed about this because I think too many devs kind of just, they're working on, emulator, working on a laptop, they're on broadband, oh, super fast connectivity, oh, great, and then they create a mobile app, oh, it's really great, it's really fast this, and then they ship it out and it sucks because they've not really thought very much about this. So you need to be smart about it. So one of the things about being smart about is, first of all, is having some awareness of whether you've got a network and what kind of network you've got, because that you can actually change your UI a bit. So if you've got a heavy-duty, large data transfer you want to offer to your user, download a big load of data, it may be that if they're only on a slow network, you might want to put a message up saying you'll need to connect to Wi-Fi for this. Otherwise, you leave them with a poor user experience while they're waiting forever as this download never seems to be completing and probably times out, doesn't complete at all. So you need to make sure you don't diminish the user experience by trying to send or receive data if you haven't got a network or if you've got a poor quality network. So there's a network interface type object which has a network change event. So you just need to hook that, and that will tell you at a rough level whether you've got a network or not. So that's the starting point. And there's a whole bunch of other APIs that are useful in this. Device network information isn't actually too interesting, but it gives you information about who your mobile operator is, big deal. But more interestingly, is network available is a property, again, which tells you whether you've actually got a network or not at that time. Then the other ones is cellular data enabled, roaming, and is Wi-Fi enabled, are kind of controlled by what the user's got turned on in settings at this time. So again, it's all useful information for you. But the one at the bottom's the one that's kind of the most interesting. This is a brand new one in Windows Phone 8. The Network Information API is one of those that's in the Windows runtime. It's the same API we've got on Windows 8 Store apps. And it's got this method, get internet connection profile. And when you get one of those, you get the profile of the current network connection to the internet. So the most important bit of information, you get loads of information out of it. It's a little bit, to be honest, in Windows Phone 8, if you look at it, it's got a load of properties, and most of them are not implemented on Windows Phone. They are implemented on Windows 8, so we've got the same API, but you actually don't get as much useful information on phone as you do on Windows 8. But what you do get is the interface type, this IANA interface type. IANA stands for, anybody? I'm throwing it out to the room because I can't remember. It's International something network something authority thing something. And anyway, if you look at the docs, it'll take you to this list of network adapter types, and there's like 200 plus of these things. In actual fact, we're only interested in a few of them. So if you get back interface type other, actually that means GSM. That means like standard data connection. Ethernet, well, we're not likely to see that with a phone, not just yet anyway. And Wi-Fi, obviously, we're interested in. And this is the one. If we're on Wi-Fi, then we know we've got a good high bandwidth connection we can make use of. So again, that gives you a bit of a flavor. You're not going to get anything like, what's the signal strength, how many bars have we got, unfortunately, but you will be able to determine the nature of the connection that you're on. So that's all useful stuff. Now, coupled with that as well is you as the developer can have a lot of influence on how successful network transfers are. So you need to make sure, I mean, this is where people are lazy. We've already got a data service, a web service out there, which is giving you the data you need. So that's easy. So you add service reference, and you make a call, and you pull back all the data, and then probably, maybe in your app, you might use 5% of that data. Maybe you don't need all of the data that service offers you. So you're transferring all this redundant data over the network connection, which could be, over a poor quality connection, be the difference between success or failure. If it times out, you can't do it. So, you want to try and do what you can do to keep the data that transfers over the wire relevant to it's only what your app needs, so keep it as small as possible. And also, when you think about when objects or data gets transferred from a server to a phone, it's going to be serialized on the wire into some format. It could be XML, it could be JSON, but JSON's great. JSON is definitely the best. And then the other one is to use compression. We'll come on to that in a minute. So if you own both ends of the wire, design your web services to only expose the data you actually need in the client. If you don't happen to own, maybe using a third-party service, well, actually, even then, you might want to consider creating your own service to act as a kind of a proxy, a gateway, if you like. So you make a call to your service. Your service then calls the third-party service, gets all the data from it, and then does some tuning of that and refactors it into smaller, just the data you want, and sends it back to your phone app. So there's a couple of things you can do. I've got a good demo that sort of drives this message home. So let's just finish we're done with that. Let's go and open the serialization sample. So this solution contains two things. It contains a web service, which is running obviously on my dev PC here, and we've got a phone client, which is this one down here. And what we're going to do, first of all, this is let's just build it. And let's look at what the service actually exposes. View in browser. It will initially error, which is actually to be expected, because I have to change from localhost, and this I'm going to come on to in a minute, later on in this presentation. Change it to the actual host name. And this is the root. This is an OData service. How many of you have worked with OData? A few of you there? Yeah, okay. For those who haven't, it's really cool. OData is a really cool way of exposing a relational database, or actually any collection of objects, enumerable collection. It could be in-memory or plain old CLR objects, whatever, but it actually works very well if you can create a WCF data service, or you can use ASP.NET Web API, and you can create a service like this in just a few minutes. It's actually got a SQL Server Compact Edition database with the Northwind database data in it, which is underneath this, but that's kind of irrelevant. But this is the root of the data. These are the base tables of this. And you can navigate just by changing the URI. So I'm going to change that to suppliers. And now it's going to give us a list of all of the suppliers. Just make that a bit bigger. So this is the suppliers data. You get a lot of information from this feed. It's an atom feed format. The actual values of the properties of this supplier are actually just this bit here. Oh, go away. Just this bit here. But you get all this other stuff as well. You get all these cross-reference links, which is very handy because it tells you, for example, if you want to see just the second one in this collection, it tells you that actually the href here is actually suppliers 2. So you can say, okay, I'm only interested in supplier number 2. So now we've just got supplier number 2. And then you can navigate the relationships in the database just by changing the URI. So it tells you here, if you want to see what products suppliers 2 supplies, then you can just change your URI again and put products on it. And now we'll get the products that supplier. And you can see how easy it is to navigate. And the other good thing about this is that it supports these OData services, supports over the wire for serializing these objects, this format, which is XML atom feed, and also JSON. Which brings me to the actual demo. So let's run this thing up on the emulator. And it's not stunning UI. It's not meant to be. So all we're going to do is we're going to call this service and get what I want to get the suppliers data. I want the collection of all the suppliers in this database. So I'm going to start off with this one, OData atom. And we've got a breakpoint. And what we've done, we're using the web client, and I'm just downloading the default format from the service, which is this URI. And it has returned to us actually a bunch of XML. This is actually exactly the same XML we were just looking at in the browser. And I'm looking at the length of in each case. So that was nearly 29K in order to get the supplier's data down using the default atom feed. Now the next one is kind of the same. We're still using web client, but this time we've put on it this header, an accept header, which says to the service, I would like your data sent to me in JSON, please. And actually, I want this OData equals verbose format. So this one has given us the same information, but it's in JSON. Now, JSON, if you're not familiar to it, it's just another serialization format, but it's much more compact than XML. But you still get all this this cross-reference stuff in it as well. All this thing up here, all this stuff is through it. So it's still not just the data, but it's much more compact because now we're 15K. Now, since WCF Data Services 5.1, they now support a thing called JSON Lite, which does away with all of those cross-reference stuff. If you don't need it, don't ask for it. So this actually is now the default format for JSON. So all we do is accept the accept header to application/JSON, and now what we get back is just the data. All that cross-reference stuff is gone. Just the data. So that's that's probably an improvement. If we know what we want, we don't need all that cross-reference stuff. And indeed it is. Now it's 8K. And then the last version of this is exactly the same, except that we have, before we've sent it, we've zipped it on the server and compressed it, so it looks a bit like that. And this one is 4K. So there you go. That's the same data. So, which would you use? No-brainer, really. And if you're running over a poor quality network, that's going to be at least the difference between a great user experience and not so great, or it could actually mean that obviously this is a small data set, but think of a larger data set, you're going to get even more benefits from that. All right. So that's just a summary of that, confirmation of that sort of results we just saw. Yeah, which brings me nicely on to implementing compression. So actually, from the client side, you don't have to do very much particularly, but we have a bit of a problem in the Windows Phone 8 SDK because there is this object in the full .NET framework and in Windows 8 Store Apps, which is this thing called a gzip stream, which is very handy for gzipping and so compressing and decompressing streams. We don't have it, but we have got the sharp ziblib and sharp compress and a number of other third-party packages which have this in it. And also on NuGet, you can actually download, one of the NuGet packages you can get is the gzip web client. And the gzip web client is it's a drop-in replacement for web client. So instead of new gzip web client, new web client, you just include the NuGet package and then your new gzip web client. But to use it thereafter is exactly the same. But internally, it actually uses the sharp ziplib stream to compress and decompress data that's going over the wire. So it's very, very easy to use. Now, on the client side, this is leaving aside the gzip web client, which hides all this for you. What actually it's doing internally, and this is how you would do it with the HTTP web request, you need to, on the client side, all you need to do is tell the server on your request. So obviously in HTTP is a request goes to the server and the server sends a response. That's how it goes. So on the request you send to the server, you tell the server that you can handle zipped content. So the way you do that is you set the accept encoding header and you tell it what kinds of compression you support, gzip or deflate, something like that. So we're supporting gzip. And then when you get your response back, now the server might not support compression, so you need to check whether you have actually been sent compressed content. So you need to look in with a bit of code like that's highlighted there, if response content encoding contains gzip, so if the content encoding contains gzip, then you know you've been sent gzipped content. So then all you need to do is pass your response stream through a gzip input stream object and that will decompress it. Nice and easy. And otherwise, you've got uncompressed data anyway, so you just handle the response stream directly. So that's on the client side. You don't have to do very much. That's it, really. This is just for completion. I showed you briefly OData there, and my demo there, the one I showed you a minute ago with the 4 different ones. I was actually doing raw HTTP requests to work with an OData thing. There is another API which allows you to work with collections of objects that are surfaced through an OData service. You use a link statements to actually interact with it. So you're working with a collection of objects just as if they're in memory, but they happen to be on the remote server. So this is the OData client library. I'm not showing you a demo, but I'm throwing this in just for completion, so you've got all the bits and pieces. That you can also intercept the outgoing requests and the incoming responses, and all you need to do is to hook up a reading-writing the writing request event and the reading response event, and these are the event handlers. So at the writing request event handler there, all you're doing is adding that accept encoding header onto it, saying, yes, I understand gzip. And then on the reading response, again, we're looking to see whether the response has been zipped, and if we are, we're passing it through a gzip stream. So same kind of thing, but that's just for completion of that. Yeah, now, like I was saying, so the client side is fairly simple. Now, it turns out, probably you're going to want to try this yourselves. And so what you will do, of course, is create yourself a OData service or something in Visual Studio 2012. And then you will hook up the code I've just showed you in the client, and you'll expect it to work, and nothing will happen. That's because IIS on Windows 8, and you have to do Windows Phone 8 dev on Windows 8 box. Now, IIS 8 does not have compression turned on by default. So you need to go and turn it on. So first of all, you need to go into turn Windows features on and off, go into Internet Information Services, and if you drill down into performance features, there's a couple of checkboxes in there for static content. So this is static pages that are being served back to clients from the web server, and dynamic content. So we're talking about dynamic content because when you hit a web service, obviously you're going to get differing data in different circumstances. So those need to be checked. So that's the first step. Then you need to go into IIS Manager and do some configuration. So all you've done there is you've enabled the feature, but you still haven't turned it on in the web server. So you need to go into IIS Manager, and you select the top line there, which is Rockstar in my case, and you need to go into compression and turn dynamic content on in there as well. And then you also need to drill down a bit further into the configuration editor, and there's some features in there. So I'll just show you. Actually, I'll show you on my box. It would be a bit simpler. It's one of those things that is easier to show in practice than it is actually in on slides. So here's IIS Manager, Internet, and so there's all my websites I've got configured in here. Now this is where you want to select the top line, and here's compression. So open that feature. These will be unchecked by default. So you need to check those. That's the first step. And then the other one I was talking about, down the bottom here, you'll find in management this configuration editor. You need to open that. Now this actually gives you access to so many features of IIS. So don't go in here and just change stuff at random because you could easily break it. There's all sorts of different categories of stuff. But the one we're interested in is the one that it's actually focused on, because this is where I've been working, which is HTTP compression. And on this page, you'll see dynamic types on here. And I've got count equals 9 on here at the moment. Click that little button and you can edit the types. Now what this is a list of all of the MIME types that are going to be compressed by the server. Now by default, what you have is the top 5 lines. So it will compress text, it will compress JavaScript and message stuff, whatever these. So these are MIME types. But this one, ** means that everything else is not compressed by default. So what we need to do in this case, for my service, which was an OData service, as you saw, the different MIME types that my OData service can return are these ones here. Application, atom.+xml, JSON, The docs say to do this one. To be honest, I'm not sure quite why, but hey, you know, I'm just going to do it. And then there's the other one, the JSON verbose. So the way you can add additional ones into here, you just add, and then you set enable to true, and then you can put your MIME type in here. So whatever, and that will add it in, which is a bad idea. So I'm going to remove it again. So that's the configuration side of things for the server. So that's what that was all about, the dynamic types. And after that, we should be in good shape. But actually, compression on the wire is one of those things that's actually hard to see. It's hard to know whether you've done it or not. How does it work? So this is where you want to bring another tool into your toolkit, which is something that can sniff packets on the wire. And Fiddler is one of them. Wireshark's another. Fiddler's the one I use, so I'm telling you how to do it here. I'm told that Wireshark is a bit easier than this, but this is the one I'm going to tell you what to use. So Fiddler's a free download. It's a third-party tool. And we need to do some configuration on that as well in order to be able to monitor stuff that's going from the emulator to our service. The first thing you need to do on Fiddler is to allow remote computers to connect. And again, I'm going to switch over to my machine just to show you this. So we're done with that. I don't want to say any changes. So this is Fiddler. And on the Tools menu here, there's Fiddler Options. It's a bit small for you, but that says Fiddler Options. And there's a load of different things on here. There's a tab called Connections. And this one, Allow Remote Computers to Connect. You have to check that one. That is unchecked by default. Now, why are we allowing remote computers to connect? Well, this is because the emulator, or indeed a real phone, if you're working against a real phone, they are remote computers. Even the emulator is a remote computer. It's a Hyper-V virtual machine. It's Hyper-V. It's running. It's completely virtualizing down to the hardware. So it's not kind of a simulator, that's some app that's running on your PC. It actually is a separate computer, the emulator. So it's a remote host. So first of all, we need to check that to say that, OK, we're going to allow remote host to connect to Fiddler. So that's the first stage. And then you need to go into the rules and customize rules. And this is a load of scripts that execute when Fiddler when Fiddler's working. And there's all sorts of header stuff and this sort of thing. But the interesting one are these functions: on boot, on shutdown, on detach, on before request. This is the one. Now, scroll down to the bottom of this, and at the end of it, I have added this, which is to reroute connections from remote host to port 80. So if the request that Fiddler gets is actually targeting Rockstar port 8888, then what it's going to do is reroute them to port 80. So what we're doing is we're configuring Fiddler as a reverse proxy here. So that's that. I'm going to leave Fiddler running because the next thing I'm going to do is just show you a demo. So we've got nothing happening at the moment. Let's go and find my next demo. So this is a variant on what we were looking at before. It's very simple. It's making calls to, that's the UI, it's loading, and all it is going to load yet again, our friend, the suppliers, and it's going to show them on the screen in a list, and we've got a button at the bottom with some menu options, and the idea here is that you can turn on or off compression, and the code simply uses the web client, two flavors of it, either the vanilla web client, and we're getting the JSON format, or the gzip web client. So I've added the NuGet package for that gzip web client, so that's going to be compressed. So we can then see in Fiddler the effect of that on the wire. So here we go. First of all, I've got, at the moment, compression is currently off. So I'm going to hit that button. It's going to make the call, and it tells us we've had 17,002 characters back, and it shows it on the screen. But that's kind of boring. But what's more interesting is over in Fiddler, we've actually got our call has been monitored here. So you can actually go and see that the response body, above there's the request headers, so there was no actual request headers of interest in there. And the response body was 17,002 bytes, but there was no compression. So the other one, of course, is now to turn on compression. So I'm going to turn it on and then make the call again. Now it still says we've got 17,002 characters, but that's because gzip web client has already decompressed it at the point at which we're measuring it in the app. But if we look at that, but go back to Fiddler and actually look at that one, then we actually had an accept encoding header here of gzip on the request that came through, and the response body was 3998 bytes, and we could see that gzip encoding was applied. So that's one useful, it's actually very useful. You can look at the JSON as well, and it's good for monitoring stuff that's happening on the wire at Fiddler. Very useful tool. All right. So any questions on anything so far? All right, all good. Right, next topic in my little tool bag of useful stuff, network security. So we've now got our nice efficient network transfers happening, but we want to make sure that people can't snoop on it. So you can obviously use SSL to encrypt data comms. If you've got a regular server cert issued by one of the major certificate authorities, it will all just work because all the root certs for all those major certificate authorities are already pre-installed into Windows Phone 8. Now, if you want to do an enterprise app and you're using your own, you've got Windows Server set up as a certificate authority, you're issuing your own certificates, then you can, and you've secured your web service, the server side, using your own server cert, you can actually install the certificate onto Windows Phone. It's a little bit clunky. You have to expose the certificate file in some way on a website itself, and then you can just tap on it in the browser and it will download it and install that root certificate onto the phone, and thereafter it will trust it will trust that server, and the communications can happen. Unfortunately, we can't handle client certificates on Windows Phone. So in that scenario in SSL, which is how most of whenever you go on an SSL secured website on the web in the browser to do shopping or whatever, what you're doing is you're verifying the identity of the server, but the server doesn't actually know much about you. You're not verifying the identity of the client. So in kind of high secure scenarios, you actually have mutual certificates. You have a server certificate, you also have a client certificate, and both check each other's. So we can't do that client certificate story on Windows Phone. But we can encrypt effectively on the wire. And encrypting, of course, is only part of the story. Now, all we've done there is secured the data in transit. But on the server side, we also need to make sure that the service knows who you are, so it can figure out whether you're allowed to access these services or not. So we need to pass some kind of credentials over to the service. Yeah. The question is, there's still no VPN support in Windows Phone. No, there isn't VPN support in Windows Phone. It's being considered, so we have nothing we can talk about at the moment. I am working with some partners on a private solution on that, so I expect something to happen. But there's two thoughts about that as well. I mean, VPN obviously is something that a lot of customers trust and want to use. Downside of that is you could argue that sometimes you're opening a big secure pipe to open up all the horrors of the internet to your device and things. So there's pros and cons in both ways, but yeah, we don't have it out of the box at the moment. So at the moment, for authentication, we're going to need, we probably want to use for internet-connected devices, we're going to use basic HTTP. So you're passing a username and password over in the HTTP headers over the wire, but those go in clear text with basic HTTP, so you must always use this form of authentication alongside SSL to encrypt the transmissions as well. Then it's a secure solution. If you're connecting over a LAN for an intranet, then we've got Windows and Digest authentication support in Windows Phone 8. This is an improvement. One of the benefits of that shared core we have with Windows 8 is that this kind of support has come onto Windows Phone as well. So we've got NTLM and Kerberos. So in order to add your credentials to a request, it's very simple on the client side, something like this. We create ourselves an instance of HTTP web request, and then you can just set the credentials property to a credentials object and pass the username and password through that. And there's another version of that, another constructor where you can specify a domain as well. So that's easy. But, of course, what you're going to do every time you make a request, are you going to ask the user for those credentials? No, of course you're not. So this implies another problem, that we need to be able to securely store credentials on the phone as well. Now, if you've got enterprise devices that are fully managed and connected to the domain, then you can enable BitLocker on Windows Phone, and all of the storage of the phone is going to be encrypted, the physical storage. So you could argue that allows you to secure your data securely on those phones. Now, obviously, for most consumer phones, that's not an option. So you're going to need to ask the user at some point for credentials, and then you're going to need to store them. How do you store them securely? Well, there's a very, very handy API that helps with this called protected data. It's sometimes known as its older name. It's been around forever. It used to be known as DPAPI, Data Protection API. And it's supported on big Windows and on Windows Phone. And this allows you to encrypt them. Now, the problem with encryption is always every encryption you've ever done needs a key as well. So you've got a kind of a chicken and egg problem. You can encrypt your data, but then you need to secure the key. So how do you secure the key? What, you encrypt it with another key? No. So protected data gives you a solution for that problem, because the key is machine generated. It's created by that computer, by the phone. And it's the phone OS, if you like, that's doing that encryption for you. What that means is that anything you encrypt using protected data ends up in storage. And even if somebody got your phone and tore it apart and used equipment to pick all the bits and bytes off out of your flash storage and happened to figure out where that secure data was stored, they still wouldn't be able to decrypt it because they haven't got the key. The key is owned by the machine, and the key is not accessible. So this is a good solution, and a lot of apps you'll see, the first time you run it, they'll ask you for some credentials, and you're not asked again. Even things like the built-in email app. You ask for your credentials, it's stored, and obviously every request thereafter, they're being silently attached to every request. But the only time you'll ever get prompted again is if you make a request and you get a password challenge because you changed the password, probably through your PC or something. So yeah, you'll only need to challenge them for these credentials again when required. It's quite easy to program this encrypted protected data API. You get a byte array of the data you want to encrypt. You'll then call protected data.protect on that byte array, and that will give you back another byte array, but this time it's all encrypted bytes. And then this bit, the isolated storage file stuff, is just storing it away into a file in your permanent storage, down to the bottom there. So the actual encryption bit is actually just the top couple of lines of that. And then the reverse of that, read it out of the file again. That's 2/3 of that slide. And then down the bottom here, protected data.unprotect. And then you've got it back to clear text. And then you can turn it back to a string. So very simple. And that's really the key to securing your credentials. All right, let's go and delve into the tool bag a little bit more. And let's see if we can... I'm seeing is if I can get some water. Here we go. Then we're going to actually look at something else a little bit different, which is storing files in SkyDrive. So why SkyDrive? Well, A, because it's easy to use, and B, because it's a quite nice and easy solution for allowing your users to back up data from your phone app up to the cloud. In SkyDrive, it's their storage, so they're connected to it, and it's a natural thing for them to do. Also, actually, it saves you, as the app developer, going to the expense of sorting out some. And I shouldn't be saying this, of course. Well, I should be encouraging you to purchase Windows Azure storage up there and storing it all up there, which, of course, and you can do great stuff with Windows Azure mobile services and things. But if you've only got simple data storage needs, or you're offering it as a convenience to the user, then SkyDrive is a great solution. Because everybody who signs up to the Microsoft account gets a certain amount of storage. It's not inexhaustible, of course, and you start filling it up with photos and things, it will fill up. But it's there, it's available, so why not use it? And it also opens up these nice scenarios where you could create a phone version of your app and a Slate version of your app, and they can share data through, you have common data stored somewhere in the cloud. The SkyDrive is a good place for that. So you have this nice connected experiences, this idea that you could start something on one device and then later on pick up a different device and pick up exactly where you left off, because all the state and the data for that operation has been stored. And it's really easy to use because it's SkyDrive, and Windows 8 slates are kind of linked in with all of that stuff, and the Microsoft account. They don't even have to sign on to use this. If you've got a Windows 8 Store app, they won't even need to sign on. You've got a single sign-on thing on Windows 8. There is an initial logon required on Windows Phone, and I'll show you that in a minute. So how do you use it? Go and get the Live SDK. There's a download for that. And actually, if you notice there's also Live SDKs for Android and for iOS. So again, you could use this SkyDrive storage as storage for apps running on all the mobile phone platforms, potentially. You will need an application ID or Live Connect client ID. So you need to go to manage.dev.live.com/applications, and you sign in there with your Microsoft account, create a new application, and that will give you back a client ID and a client secret. That check the mobile client app thing, it's actually referring to the radio buttons at the bottom there, which maybe look a bit small to you. Mobile client app, yes or no. If you say no, it will ask you for a callback URI, because this is obviously can be used by web sites as well. So just make sure you check yes on that. And that will give you back this client ID and client secret, and you will use that in your code. Then you've installed the SDK. You'll need to add a reference in your app to Microsoft.live and Microsoft.live.controls, and there is a sign-in button control in there as well. So you could optionally add that into your toolbox and allow you to drag it onto your apps. And then build your app. And it's actually, the other good thing about the Live SDK is it comes with these fantastic sample apps, which really give you everything you need to know and all the demo code you'll ever need to know about interacting with SkyDrive. You can browse it, upload, download files, and there's also a really, really cool one which uses the background file transfer service. So I'm going to show you that. Okay, so we're done with you. You can go away. So this is the sample solution you get with the Live SDK. As you say, you've actually got loads of different 5 projects in here. So I'm going to start with the... Oh, thank you. Here we go. Thank you so much. Yeah, so we've got 5 projects in here. API Explorer, background transfer, core concepts, live login, and stream, upload, download. And I'm going to do this core concepts one. I'm not going to dig deep into the code. You can download this and have a look yourself. I'm going to run it on the device. So I'm going to go over to, they told me, 7. Yep, there we go. Let's just start this guy up. All right, so this is the core concepts one. You see that right? Yes, you can. Here we go. And this is the sign-in button. You can customize the icon and the text. So this is the default sign-in. I'm now going to sign into my Microsoft account. So you have to do this the first time in the app. It will save it thereafter. And then I'm going to put in my ID, if I can find it. Oh, there we go. The reason why I'm doing this on a device rather than on the emulator is simply so that I don't have to show you my password. So there you go. So hit sign in. So we're now signing in, and now we're into, you'll see this standard screen will come up, which is asking for permission. Let this app access your info. It tells you what it will potentially allow this app to do. And then now we're into this app. This is the sample app. We can actually browse SkyDrive. So let's go and have a look what I've got on my SkyDrive. As it turns out, accumulated years worth of rubbish and some useful stuff. Lots of documents and a couple of project stuff, some music, pictures and all this sort of thing. So these are all the top level folders. And we can also upload files from here. So I can select a picture. So actually what I'm going to do is take a picture of you very wonderful people in here. There we go. So I've got the picture will now be in the camera roll. So I can go back to my app, select a picture, camera roll, and there you are. So now that has gone up to SkyDrive. And if we go back and browse SkyDrive, we should see it on the list there. And there it is at the bottom, WP JPEG. So that's one of the samples. Now the other one though is kind of actually almost more interesting, if you like. So I'm going to close that one, and I'm just going to deploy the background transfer one to the phone. So that's the startup. That's the device. So has anyone used the background file transfer service? Okay, one of you there. So this is one of the kind of hidden gems, if you like, of the phone SDK. So if you need to transfer a file from your app to somewhere, to a service, you could obviously write some complicated code with all the error handling and all this sort of stuff and build it into your app. Or you could simply ask the OS to do it for you, which is what the background file transfer service is all about. And it's like a few lines of code, and it's really, really easy to do that. And this uses this as well. So I'm just going to sign in again, because this is a different app, of course. So unfortunately, I have to sign in for this new app. Thereafter, like I say, it stores it in persistent storage. So if you remember now, we've got, this is the standard thing, we've got that, I'm going to download, actually that same picture, I'm going to download it into this app storage. So I'm going to download it from SkyDrive. So we're going to go and find, it's going to find, there's all the folders, the top level folders, and we're going to scroll down, find that picture again. There it is. I'll select it, and I'm going to hit download. And that's going to store it down in my permanent storage. It's downloaded to the shared transfers folder. So when you're using the background file transfer service, everything goes into the shared transfers folder or a subfolder of that. So it's downloaded it. So that's good. And then what I'm going to do, before we go back to that, I'm just going to switch to my PC again and actually go off to, let's go off to there's my SkyDrive. Let's go to skydrive.com. Signing in, and this is it, and there's that picture. But before I'm going to actually go, there is the picture. I'm going to go back, and then I'm actually going to, sorry guys, I'm going to delete you. So you've gone from SkyDrive, there you are, it's gone. And then actually back to the phone app, I'm then going to send it back again. So we're now, this is where we were, we just downloaded that. I'm going to go back, this time I'm going to upload. So now we can navigate through. This is now looking at my isolated storage. I'm going to go off to the shared folder. I'm going to go to transfers. And there is that picture again. Now I'm going to upload it back. But I can actually, now I've done it, I haven't even let it finish because I can close the app, but the OS is just going to take care of it. So you can see how this is a nice, easy way of adding in a feature like back up something to the cloud, because you don't even have to wait for it to finish. You can just, it will just happen. And if I go back to the PC, even though I didn't let it finish, and just refresh this, You'll see that it's completed in the background because the OS has taken care of it. Background file transfer is really, really cool. Yes, Ian? So yeah, with the background file transfer service, it is an OS service. So when your app runs again, and you have to run the app, then you can look at the status, the completion status, and you'll get the HTTP response and this sort of thing. So you can track whether it actually completed or not. So yeah, you get a list of all your you can have I forget, is it 25 or 50 file requests active at any one time. So you can find out the status of any one of them. All right. Now then, so that was SkyDrive. Oh yes, this lovely topic, accessing local services from the emulator. So, how many of you are Windows Phone 7 devs? Okay, just a couple. Okay, well, Windows Phone 7 development, where you were using the emulator and accessing services, you can create yourself a web service, a website, dead easy, just worked. Because the emulator on Windows Phone 7 was actually using an older emulation technology, which is Virtual PC, and it had this shared NAT, shared networking thing, and they did this dirty hack, basically, that allowed you to access URIs using a local host URI on the emulator, and it would automatically connect to the service on your PC. Now, if you think about that for a minute, that's just wrong. It shouldn't happen. Because when you talk localhost, you're talking about services on the same machine. So, you know, HTTP localhost on the emulator means something running on the emulator. Well, no, I'm sorry. Windows Phone is not yet a web server, so that ain't going to work. But it did, and it was a nice convenience. It made life easier for developers. Now, on Windows Phone 8, that doesn't work anymore. Because the emulator now, I told you this before, is a full Hyper-V virtual machine. It's a completely separate computer. So you have to, if you want to access services running on your dev PC, you've got to actually use the correct IP address or the correct host name of that host PC. So actually, that's it as far as the client's concerned. Nothing complicated in that. The complication comes when you actually are creating your websites, your services, that you're developing a solution, both ends of it, and you've created yourself maybe an OData service in Visual Studio 2012. Because in Visual Studio 2012, when you create anything using ASP.NET or any of these technologies, it runs in something called IIS Express by default. And IIS Express is this kind of cut-down version of IIS. It actually is running the same core web server engine, but you don't need like admin privileges. So it's better for dev shops where they're not happy with devs' machines having all that admin privileges. So it runs in IIS Express, but IIS Express also comes with, it's all security locked down, of course. Everything is locked down these days. So anything that runs in IIS Express only will work if you are using localhost URIs. So it means you can do dev on a dev PC and you can check it out in the browser on the dev PC. It all works. It's not going to work if you want to access that from a remote machine such as a phone. So this is it. This is the gory details of how you fix this problem. How do you configure a website you've created and that's running in IIS Express to accept remote connections? This is what we're talking about. So first of all, create your website. There's an example of it. Maybe that's an ASP.NET or maybe it's an OData service or whatever. And if you run it, you'll see that it will run it on localhost on some randomly allocated port, 18009 in this case. And then you need to go into your My Documents. You'll find in there a folder called IIS Express, another folder in there called config, and under there is a config file called applicationhost.config. And you need to edit that. And inside there's a section, it's an XML config file, there's a section called Sites, where you will find entries for every website you've ever created in Visual Studio. And down at the bottom will be the new one you've just created, and it will have a binding statement like that. The binding protocol, HTTP, binding information equals star dot, then the randomly, whatever port number it gave you, colon localhost. So you need to edit that and change it to your correct host name. Then you need to go back to Visual Studio and basically close your solution. It says on there, remove your website from the solution and add it back in again. Actually, probably you don't need to do it. Just close the solution and reopen it again. And then if you try and run it in the desktop browser, actually it will kind of try and open it at your hostname, whatever port. At this point it will fail, because you'll need to now run a command prompt, and you need to do, well, you need to do two things. First of all, you need to open that port on the firewall, the whatever randomly numbered port it is. But also, most importantly, you need to do this thing, you need to add a URL ACL. Netshare HTTP add URL ACL, URL equals blah, 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 blah. And that allows that port to be used. So it's already complicated, but that is what it is. So let's just run through that. So off to Visual Studio. We're done with Microsoft Live. Let's go and create ourselves a new project. And we're going to create ourselves a web project. Yeah, question there.
Do you have to do the same things if you want to access it from your phone? If you have your device, you're on a wireless network and you want to access the website from there.
Yeah.
You have to do the same thing.
So yeah, so the question was if you got on a real phone and you access a service running on your dev PC, do you have to do the same thing? So yeah, this is really what we're talking about here is the server-side configuration that will allow that scenario. Yes, so you'll be able to connect to it from any device that's on the same network. Yeah. So I'm in Visual Studio. And I'm going to create myself a new project. I'm going to create myself, I don't know, let's have a MVC4 application. TechEd website, WS. We'll say OK. And yeah, we'll have a mobile application. We'll say OK. And it's going to create itself a mobile application. And it all should work. It's just building all that stuff into this website, loading all the different references. And we've got a working website which you can try and use. And it will, if we run it in the browser, we can see that actually it's given us a port of 33775. Okay, so that's very good. And there is our website. And I could try accessing it on my phone, on the emulator, and it isn't going to work at this stage. So first thing then, I need to change that to allow remote connection. So go off to My Documents, IIS Express, config, applicationhost.config, and we go down and down and down and down. Here's this site section. These are all the sites I've ever created. Go down the bottom, and there is the one, 33775, the TechEd WS one, and I'm going to change that from localhost to being Rockstar. Case doesn't matter, but be consistent. Rockstar. Save the changes. Back into Visual Studio. Stop that. We're going to just close the solution and reopen it. And if you try and run it now, you'll get an error. It says unable to launch the IIS Express web server. Failed to register URL HTTP Rockstar. And this is what I was talking about. This URL ACL is needed. So let's go off and fix that. So I need myself a command prompt. I might even do a command prompt as administrator. Run it, run as admin. And we say, yep, we'll do that. And here we are. We're going to do all that stuff, which is net share. We're going to HTTP add URL ACL, and then the URL is equal to HTTP : rockstar port. What was that port? 33775. Is that right? Okay, hope you're right. / user equals everyone. So that's the URL reservation. We can also do net share, add firewall. Well, actually, this is tedious. Tell you what, I could do it through the. I'll do it this way. Yeah, you can do it through the UI as well. Actually, firewall add rule name equals brackets IIS express brackets non-SSL brackets action equals allow no spaces equals allow and protocol equals sorry oh thank you very much great peer programming, love that. Protocol equals TCP direction equals in local port equals 33775 going says okay. Right, so now we can run this. It will say fail because it still tries to open it on localhost up there. So we can now say rockstar 33775 and it's working, yay! And back on here as well, we can also go onto here and say, yeah, we're good with that. And then we go to HTTP, oh, get rid of that, HTTP, rockstar 33775. And if the gods are with us, yep, there we go. So that's it. It's a painful process, but as you can see, that is, it does seem to work. But it is documented in the docs. Right. Right, just to finish, a very quick look at some other interesting technologies we've got, NFC and Bluetooth. So this is a whole new set of APIs in Windows Phone 8. We couldn't do anything like this. Two new local communication methods available, Bluetooth and NFC. So Bluetooth is obviously for up to 10 meters. And we've got two scenarios we support with this. First of all, this app to device. So this is where you've got something that's has been paired with your phone. And so this is how you can actually control radio-controlled helicopters and all this kind of cool stuff, or central heating controllers, or anything that actually supports Bluetooth. You have to program the protocol yourself, but you can do all that sort of thing. And the other one is app-to-app, where you can actually, one app, your app is running on a phone, and it can discover another instance of itself running on a phone nearby and set up a Bluetooth connection between the two. So you can do multiplayer games, which is really interesting. The other one is NFC, which is really for very, very close, to between 3 to 4 centimeters. That data rate of 424, forget it. That's the theoretical maximum. You're going to get a fraction of that in practice. So it's not for high data volumes. It's for small data connections, a small bit of strings on things that are being exchanged. And there's no real authentication as such at the moment because you're assumed to have connected these things. You know, it's a deliberate action to connect them. And you can read and write to NFC chips, tags. You can exchange strings. You can exchange URIs. But the other also interesting one is that you can use it for connecting devices together. So you this tap to connect thing. So the NFC is the kind of initial point of contact. But then what you'll get is a Bluetooth or a Wi-Fi connection between the two. So a simple transfer of data, or this one to set up, what you get is a stream socket, and there's this peer finder API. So this is how you use the proximity device.get default. First of all, we make a call to that. If that returns non-null, then you've got NFC support in the phone. So you might not have NFC on all phones, so that's the first thing you need to do. And then you can use this peerfinder.start to look for connecting devices. And then there's this triggered connection state changed event handler. You can also connect to Windows 8 machines. This works between phones and Windows 8 slates that have got NFC in them. And then that triggered connection state changes. A whole bunch of different statuses can come back from them as it goes through the different bits of its life cycle. The important one is the completed one. So on triggered connect state.completed, you'll get a stream, in the args that comes back from that, you get a stream socket instance. And this is a channel you can read and write to communicate between apps. And that will work with Bluetooth by default, or allow infrastructure means Wi-Fi. So on phone, that means Wi-Fi on the same LAN. Wi-Fi Direct is supported on Windows 8, but that's not supported on the phone, I'm afraid. So just a very quick little demo to show you what that looks like. So first of all, let's go to these guys. So I've got two devices, and I've got the standard sample on here, which is already running on this one, which is the Bluetooth sample for a chat application. But you see that there's no contact here. So this one you could actually just join, and at this point it's looking for peers that are also seeking other ones. Now this one hasn't joined the chat yet, so it says no peers found. So this one actually now will do its own refresh peers. It will find the other one, so we can tap on that and connect to it. And at this point, you're going to see the code on the other app is going to say, oh, you've had an incoming chat request. Do you want? And then you ask for permission from the user, and you say, yes, OK. And then you can actually obviously type messages into here and send them across, and you've got all a chat going on. And that is happening over Bluetooth, so it can be up to 10 meters away. I've got another app on here, didn't mean to turn that off, which is one that I've got in the store for free, you're pleased to know, which is a simple tic-tac-toe game. Now this one is currently not running at all, this phone. It's not running on this one, but this one I can say start the game, and then we can use NFC to tap to connect. So I can tap them together, and this has got a prompt on it. It says open app. Someone wants to use tic-tac-toe Bluetooth with you. And now we can actually obviously play a game, and so we can actually play a game, and this one being stupid doesn't know how to play it, so of course we've got somebody to win. Now, the other thing that's interesting with this as well, I can go down to tic-tac-toe Bluetooth, and I can uninstall, oh, maybe not that way. Maybe I'll run it this way. I can take it off here, this one, uninstall, and then at this point I've also got on here tap to share app, so I can actually share the store URI, and that says launch store. Someone found something, so you can actually, this is a nice way of exchanging your app with other people as well. And it goes to the store, it will find well, actually I've got no connectivity on that phone, but it would take you to the store page, then the user could install the app, and it's a good way of exchanging your app with other people. Right, I think we're about done. So that's a very quick look. That's the code for doing a tap and share. Very, very simple. We've got a publish URI message down there to publish the store URI. That's the store URI, zoom, navigate, for that particular app. That's all the code you need for that kind of thing. Yes, question? So you... So the picture sharing protocol, if you like, is Windows Phone only, yes. So that works between phone devices and with Windows 8 slates. But I'm not sure what you'd need to do to exchange with an Android device, for example. So. Yeah, well, hopefully we'll see. I mean, you can exchange like V-cards already between Android and Windows Phone devices over NFC. That works great. So maybe we'll see a bit more collaboration. And it's trouble with NFC. It's one of those emerging technologies, so I think standards are still being defined in this area. Yeah, I'm not aware of what the differences in protocols are between the different phone platforms for that kind of thing. It would be obviously a good thing if we could all get that all to work between the different manufacturers' devices. Okay, so we're done. That's what you all learned about. Use async and await, being smart about data transfer, compression, credentials, SkyDrive, local services, loads of stuff, NFC very briefly at the end. So I hope that's all been very illuminating and useful to you. Now, while I go through these last things, if we can start collecting, if you haven't filled in your little tag yet, if you could fill them in, and then we can collect them now, if we can. Have we got all the cards for the draw? You've already got them all. Okay, great, excellent. So you've all handed them in. Excellent. Okay. So I'll just then. These are all the sessions we've got on. We're currently in the middle of Wednesday, so good session coming up next about building for both mobile security and C this afternoon. Then on Thursday, speechifying. If you haven't seen Mr. Rob Miles performing before, he's a hoot, a very entertaining guy. And he's also using background agents and there's management. And I'm doing a session first thing on Friday, which is about the SQLite database. So if you want to know about that, please come along to my session in this room at 8:30 on Friday. And we've got a whole bunch of hands-on labs. And if you come down to the booth, we're doing presentations. There's also draws. If you can go into draws for winning a phone there as well. If you just need to spend 20 minutes of your time with us and you go into a draw we're giving away 5 phones per day at the booth, and lots of interesting stuff there. And this is where we are, so at the Windows Phone breakout session. So let's do the phone. Sorry?
Like a poker?
Yeah, that's right, yes. So, well, you fan them out and I'll pick them. Yeah. Just. Okay, that's cool. Here we go. All right, and I'll pick one without looking. Okay. All right. So, the winner is, if I can find my glasses, Claudio Barzi, Telecom Italia. Congratulations.